All systems go. We are ready to launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and we have liftoff. Liftoff of the Saturn III rocket carrying the Mars astronautical spacecraft to the Greater Earth Space Station. Hello, my name is Arthur Woods. I am the resident artist of Greater Earth. I would like to introduce you to a new perception of our planet as defined by the laws of physics, a perception that could transform our understanding of our place and purpose in the universe. The overview. It's truly breathtaking. Well, it's very much fun to make spacewalks like that and to feel like you're your own personal satellite, but it's also nice to be inside here in the Ars Astronautical module, which is very convenient for observing things in orbit, but also I can use the spacecraft to travel to other places in Greater Earth. Well, actually, it was about 60 years ago on October 4th, 1957, with the launch of the Sputnik satellite, that humanity began to expand its civilization beyond the atmosphere. I would like to share with you a visualization of that process. Well, that's pretty amazing, and I want to thank Dr. Stuart Gray for giving me permission to include his work in this presentation. What this has shown us is that humanity has extended the diameter of its planet from 12,756 kilometers out to the region of low Earth orbit, where we find the International Space Station and the Hubble telescope. This region goes out another 2,000 kilometers from the surface of the Earth. And if we go all the further out to the area of geosynchronous orbit at 20,000 kilometers, we find the Global Positioning System, which controls our navigation, and all the way out to the edge of geosynchronous orbit, which is 35,786 kilometers from the surface of the planet. That gives us a diameter of 84,328 kilometers. And all of those space systems there are totally integrated in today's society. All of our communication, all of our financial transactions, our observations of the Earth and the climate, all of these things are totally in place there. And without these, our society would cease to function. And also very interesting that those artifacts out there, some of those will stay out there like a ring around Saturn for millions and millions of years. So we have truly physically extended the diameter of our planet with our technology in just in the last 60 years. However, that is not all. There's actually more to the expansion of our civilization beyond the atmosphere, and we go all the way out to the moon. Now let's redirect our Ars Astronautica spacecraft out towards the moon, and let's go for a visit. And while we're there, let's just remember that between 1968 and 1972, the United States sent 24 astronauts to the moon, of which 12 actually walked on the surface. And so the moon is a very interesting location, and let's go there for a visit. Well, that was a lot of fun, and the moon is indeed an interesting location, not only for tourists, but also there's a lot of resources on the moon, and the most important one apparently is water, which is very important for future human settlements in this region, and also the moon in the lunar soil. There's a lot of silicone, which could be used for creating vast solar power systems in orbit or on the moon. And also in the lunar soil is an element called helium-3. Now, helium-3 is very rare on Earth, but very plentiful on the moon, and this could be used in future fusion reactors. So together with helium-3 fusion and space-based solar power, we can meet all of humanity's future energy needs in a clean way, and that would contribute to restoring our environment and approaching the climate situation. So that's very, very important here. And there's also other rare metals on the moon that's been expected, and it could be very valuable for future mining activities. Well, we're going to leave the region of the moon. We're going to head out another million kilometers out to the edge of greater Earth. And on the way, we're probably going to pass an occasional asteroid because there have been about 14,000 near-Earth asteroids located, and occasionally these pass through the region of greater Earth. And yeah, future mining operations, if you could capture one of these asteroids and mine it for its minerals and metals, these could be used in space for building habitats and other devices, but also down on Earth. I mean, actually, a lot of these valuable resources could be used in industries on the Earth, so they could be mined here in a very clean way in space and sent down to the Earth for our industries there, which would contribute a lot to global prosperity. And now we're going to reach the area of the Lagrange point. Now, this is the outer edge of greater Earth, and this is where the gravity attraction of the Earth meets the gravity attraction of the Sun, and together with orbital mechanics, this creates an area of equilibrium. And in this region, it's a very interesting place to position spacecraft, such as the NASA Discover spacecraft, which you see behind me. And this means the Deep Space Climate Observatory, and it has on it a very special camera called EPIC, the Earth Polychromatic Imaging Camera. And this camera is actually studying the environment and the climate down on Earth, and it just made a snapshot of our planet every 2 hours over the course of 1 year, and this gives a very interesting animation which I will share with you. But in closing, I would like to point out the enormous amount of resources that I've mentioned here. Now, out at 1.5 million kilometers, that it creates a sphere of 3 million kilometers, and this is actually the true dimension of greater Earth. And inside the sphere is 50,000 more times the amount of solar energy that actually reaches the surface of our planet. And as I mentioned, there are a lot of resources, including the moon and asteroids. So this is a very, very attractive area for our future civilization. But the most important thing is that in order to harness all of these opportunities and these resources, it would require really a lot of international cooperation and collaboration. And I think this is preferable to conflict and confrontation down on the planet. And I think that's the biggest benefit about settling the region of greater Earth. Okay, let's look at the images from the Discover spacecraft, and they're very, very beautiful. And actually, the Earth from up here is quite far away, but we're gonna zoom in like the camera sees it, and then we'll see it. So I thank you for watching, and yeah, I hope you'll join me in greater Earth soon. Goodbye for now.